Today, I want to go through some of the tips that I've shared with others starting their career in data science, including some feedback that I've given to people that I've interviewed for data science roles. I'm sharing this information because I believe that it benefits all of us when people are better at their jobs, and this is feedback that others have found especially helpful. Depending on specific roles or industries that you want to get into, there may be different or better information out there, but these are some of the tips that will be valuable wherever you go in data science. Let's start with the big picture and something that I think will not only help you get a job, but also become more valuable once you land one. Become a good data science problem solver. This is the difference between somebody who writes stories versus one who only translates stories. Think of data science as a process where first business questions must be integrated with data and a plan is written for how that data might answer those questions best. Or think of somebody who understands properties of different materials and uses that knowledge to build a solution to the problem, such as the first person to bring together wood, fiber, skins to build a boat. This is the creative and free-form part of the process that is more like writing a story or inventing a new product. Once someone knows how the data might be used to answer the question, then it's time to translate it into a coding language or put that product into production. We have plenty of translators today, and that skill, especially with economies like India, and even the uptick in data scientists graduating from the US, will drive prices lower for that skill. It's quickly becoming a commodity, and quite frankly, something that most people can do. What is rare and far more valuable is one who can write the story or design that new product based on a good knowledge of material capabilities and the problem needing to be solved. The one who really understands concepts, strengths and weaknesses of different solutions, as well as all of the available data that's best leveraged to answer the business problem, is what the business will be willing to pay for. Number 2, get a breadth of experience and knowledge. The next part really depends on where you are in the process of getting involved in data science. It was incredibly helpful to me to have started in a role that required a breadth of tasks, including engineering for automation, to insights and analysis with data visualization. Being alone in my first role gave me the opportunity to learn a broad array of data science, and it was vital to me becoming a well-rounded data scientist. For you, this might mean taking a variety of classes or internships that stretch you in different ways, such as database management, UI design, analysis, statistics, or even just critical thinking classes. These things ultimately interconnect, and the better you can anticipate the rest of the needs of the solution, the better you're going to be able to fulfill your role in its development from end to end. If you're not in school, I'd start with your workplace. If there's any data available for you to work with, even if it just means finding some numbers to put into Excel or grabbing some reports that are already in Excel. If not, then with public databases or public data sets, such as those available from data.gov or from even a Kaggle competition, there's plenty of courses online if you also prefer more of a guided approach. So these challenges will help you grow in your ability to do the hard work of learning what your capabilities are, as well as where those capabilities might be found valuable. Number 3, study the most useful content. You only have so much time, and memorizing loads of academic materials that you're never going to use will not be rewarded. It is possible to waste your time on materials that will not make you any more capable of solving problems, even if it looks like you're building up a technical resume. I would recommend, if you haven't had much training and machine learning, to visit this link that I'll include in the description below, which includes 15 hours of some of the best videos that I've seen on the topic, giving you a really good end-to-end understanding of basic machine learning and a lot of the mathematical concepts behind it. Some of the key concepts I recommend learning more about would include things like supervised learning versus unsupervised learning, feature engineering and feature selection, things like PCA or tree-based approaches, different means of understanding and interpreting accuracy, especially for classification versus continuous variable type models. You will almost certainly not have to deal with deep learning unless you're working with incredibly wide data or more computer vision or language type of data problems. So that should probably be last on your list of things to explore, unless you do have a specific interest here or a specific need. Data insights, also very important. Practice looking at some data, such as company reports, drawing possible conclusions for what that data means. Just get in the habit of looking at data and understanding what that data is telling you about the world. Also, forecasting. This is one of the most common areas of analysis and is used for most businesses for something, whether it's predicting labor or sales. There's always going to be a need for understanding forecasting. So learn different techniques such as ETS and ARIMA, and understand that ultimately this science is not magic. It's just a simple way of repeating historic patterns into the future where it may be too complex or noisy to do, just by sight. Also, prediction versus causal inference. Something critical that many do not actually understand is the difference between causal inference and prediction problems. I highly, highly recommend understanding that difference. Prediction problems are simply a question of what is going to happen in the future. For causal inference, it's understanding what is it that gets us to that future. And causal inference allows you to build more like what if type models, understanding what would happen and being able to better predict what will happen if we apply these changes to the inputs or the features that tell us about that future. Again, extremely important. A lot of data scientists do not have a good understanding of the difference of these two. And even things like accuracy are entirely different when you're working in the causal inference space, where you're trying to produce a counterfactual or what would happen if the world was different than it actually is. So again, highly recommend understanding that. Also, interpretable machine learning is becoming important. It is very connected to causal inference. As businesses want to better understand what variables caused certain predictions, this relates to causal inference, as I said, because it's often the case that the business not only wants to know what will happen, but how that might influence what will happen. And that requires IML, or interpretive machine learning. Finally, learn some languages if you haven't already. SQL is still incredibly helpful, is one of the most fundamental languages for gathering and aggregating data. It's also a good way to understand how data relates to one another. For manipulating data, creating models, things like that. Today, R and Python definitely rule. R has a lot more training materials and resources and has an immediately easier to use and install IDE with RStudio. But Python is pretty quickly surpassing it, and in a lot of ways has surpassed it as the language of choice now, just given its capabilities beyond data science. Tools like Alteryx can also help you progress in data science without having to learn a new language and syntax altogether. It's especially popular among more business users who are looking to get into or at least dabble in some data science. I'd also say number 4, do not neglect soft skills. I have seen many people, including those with PhDs, fail to pass interviews due to a lack of soft skills. By soft skills, I do not mean being able to BS your way through a business meeting and make friends along the way. By soft skills, I mean those that can make you someone who can accomplish more with a team than as an individual. So one of the top soft skills to have would be what I would describe as confident humility. Humility is not that you pretend to be worse than you actually are. It's a good objective knowledge of your strengths and weaknesses. And it's the one who can see the opportunity to learn from others rather than feeling an obligation to be the source of all good knowledge and ideas. In many ways, it's the one who gets most excited about learning and growing, regardless of the source of that information. I'd also say being a learner is an extension of this, but it's being somebody who is curious and motivated to learn constantly. If you're someone who wants to learn, Make sure that that is true of yourself and that others know that about you, especially when you go into an interview. Don't think that you need to have all of the knowledge and experience going into that interview. After all, people want to know your potential, not just know what you already know, especially from the top employers. I'd say top employers within data science in particular are looking for people who have good long-term value, those who are capable of problem solving, critical thinking, and will continue to grow and enhance their skills regardless of what's available to them. Collaboration is also an incredibly important skill that includes a lot of other skills, such as humility, communications, and respect. If people do not want to work with you or you do not want to work with others, good luck in data science. Many data science jobs are highly collaborative and working across stakeholders and partners from business leaders, engineers, systems developers, architects, sales teams, as well as other data scientists. Finally, being able to communicate effectively is imperative. Many data scientists struggle to explain things in terms to a non-technical audience that audience can understand. You don't need much to grow in this ability. Just work on trying to explain different concepts and insights as you learn them through your courses or whatever, and write down and refine those explanations until you're satisfied with them. And then bug a non-technical friend or family member to see if you're able to communicate the basic concept in a way that makes sense to them. If not, go back, refine it some more. YouTube has a lot of videos attempting to do this as well, so you can filter those and take out the best ones. But ultimately, you'll want to practice doing this on your own because it's a skill that you need to have. If you can accomplish this, you will extend your value by being that bridge between the business and technical associates, a gap that is often a barrier to success in organizations. It's one that surprisingly, even today, that gap still is pretty significant. I would say across the majority of organizations. And so the better you can do that, better you can fulfill that gap, the more valuable you will be as a data scientist. So I could go on for hours about more specific problems and challenges, as well as skills or other resources that will help you along the journey. But hopefully this will be a helpful intro to what you will need to begin a successful career in data science, or at least begin your first steps in that career. Let me know what you think. If you have any feedback or other content that you would like to see, put it in the comments below. If you would like to be notified of future videos, subscribe to my channel. And until next time, peace.